Calculus Kids. This is Dr. Callahan with week 14 Wednesday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, let's go ahead and get started. So taking a look at as to what we are doing this week and what is due, you have your unit 3, which is on differentiation techniques that should have been completed on Tuesday. Today is Wednesday. So you're going to get started on unit 4 of your Albert IO, which is on application of derivative velocity acceleration and rate of change. So this is kind of where you're targeting. Now, I want you guys to go ahead and read your Princeton Review book on page 163 and also 211. And then after this week, we're going to start off with week 15. And just keep in mind that your week 14 assignment is due on Sunday by 11:59 p.m., just like with Math Excel. And then starting off on week 15, we're going to start off with Unit 5 on derivatives, extrema, maximum, concavity, applications of derivative. And that would conclude everything we learned in semester 1, which is also a good time for you on week 15, Thursday and Friday, to take the 51 questions of the AP Calculus exam. It's a practice test, and it's your practice test number 1. It should take about 3 hours and 15 minutes, and I know that's a big chunk of time, but when you guys take your actual test, it is also going to require you to do that. So just keep that in mind. All right, so your test is going to be on May 24th, which is right there. And on that date, you are going to be working in the Career Center starting at 8 a.m. in the morning. And you need to have a TI-84 calculator. All right, so for today, our guided notes is as follows. It looks something like this. This is your first page. This is your second page, third page, and fourth page. All right, let's go ahead and get started right up here. So these are some of the tips and advices, and I have 20 of them on things that you should be doing for the free response question, multiple choice question on your AP exam. I want you guys to go ahead and highlight the ones that you think you need to pay a little bit more attention to. So pause the video and go ahead and do that. Okay, next we're going to go ahead and go over this question. It was featured on the 2012 exam for question number 2. Take a moment and read the question itself. All right, so with that said, let's go ahead and get started. It says, as a plot of t cools, the temperature of the t is modeled by the differentiable function table between 0 to 10 minutes, where t is measured in minutes and temperature h is in Celsius. Use the data, which is part A. Use the data in the table to approximate the rate at which temperature of t is changing at time t equals 3.5. I mean, you can make a guess because 3.5 is like, right between 2 and 5. So you can make a guess between it's 60 to 52, obviously. But you have to show the computation that will obviously lead to your answer. So then what you should do is you should look at h prime of 3.5, which is a rate of change for the temperature in degrees Celsius when time equals 3.5 minutes. Well, for this, it's going to be very similar to a slope formula. So I'm going to go ahead and do 3.5, which is going to be in between 52 and 60. So let's do 52 minus 60 divided by the rate of change with it's a change of y over the change of x. So your x value is 5 minus 2. And that is going to give me a negative 8 over 3, which is the rate of change per minute of degrees Celsius for every minute that you have. And that is your answer for A. For B, it says use the correct unit to explain the meaning of the integral 1 over 10 between 0 to 10 h of t dt in the context of this problem. Use a trapezoidal sum with 4 subintervals indicated by the table to estimate this. Well, if you have a trapezoidal, you're looking at the area of this. So I look at this as height 1, height 2, base, and the area of a trapezoidal Riemann sum is going to be 1/2 times base, height 1 plus height 2. So let's just keep that right there. So the way I would answer it is the integral with 1/10 from 0 to 10 h of t dt is going to represent the average temperature of the T in degrees Celsius. And this is in between T equals 0 minutes and T equals 10 minutes. And then the second part of this question is to go ahead and, well, the first part is right here. So this is my first part, okay? Second part is going to be use a trapezoidal Riemann sum to estimate that interval. So then my second part, so this is the first part, this is the second part, is going to be 1/10 integral between 0 to 10 h of t dt is going to equal to, keep in mind that you have the 1/2 and the base are going to be constant. But what is going to change are the heights in between there, okay? So I'm going to do 1/2. Now, if you take a look at the first interval right here, the difference between 0 to 2, because this right here, remember, this is the change in y, this is the change in x. The x is going to be your base, so in between there's a 2. In between 2 and 5 is going to be a 3. In between 5 and 9 is a 4. In between 9 and 10 is a 1. So those are your 4 sub-interval bases. Okay, so then I'm going to have 1/2 base, which is a 2, times height 1 plus height 2. These right here are going to be your height. So height 1, height 2 for the first rectangle is 66 plus 60. Plus, this is your first rectangle. Let's do the second rectangle. Second rectangle, 1/2 base. My base is going to be a difference of 3. And now it's going to be between it's going to be between 60 and 52 plus 1/2. Here's your third rectangle. 1/2 times the base, which is 4. And the two rectangles you're looking at is 52 and 44. 52 plus 44. Plus, and then don't forget your fourth rectangle. And your fourth rectangle, the base is 1. 1/2 times 1, and the 2 height, 44, 43. All right, so if you go ahead and calculate this into your calculator, so what I would suggest that you do is go ahead and plug all of this in, compute it, and then you should have an approximately 52.95 unit squared. And that is your answer. All right, let's take a look at part C. For part C, it says evaluate between 0 to 10 h prime of t dt using the correct unit. Explain the meaning of the expression in the context of this problem. So in between 0 to 10, h prime of t dt is basically, it's the rate of change, okay? So it's the h of between 0 to 10, so 10 minus h of 0, which is equal to 43 minus 66, which is negative 23 degrees Celsius. So what does that mean? That means the temperature of the T is decreasing by 23 degrees Celsius between T equals 0 to T equals 10 minutes. All right, last part, which is D. For D, it says at T equals 0, biscuits with temperature of 100 degrees were removed from an oven. The temperature of the biscuit at time T is modeled by the differentiable function B, for which it is known that B prime of T equals negative 13.84 e to the negative 0.173 T. Using the given model at time T equals 10, how much cooler are the biscuits than the T? Okay, so we're talking about biscuits now because you can't have tea without biscuits, I guess. So B of 10 is going to be equal to, so at time equals 0, the biscuit with a temperature of 100 degrees were removed from the oven. So that's your initial starting point. So 100 plus, but during that time it's also cooling. So the temperature, which is cooling, has this equation right here, plus the integral between 0 to 10, B prime of T dt, which is equal to, and you want to go ahead and plug this into your TI-84, type in math, make sure you push the button 9. You're going to go ahead and do 0 to 10, B prime of T. It's given to you with this equation, negative 13.84 e to the negative 0.173 T, but you're going to do X dt, okay? So type this into your calculator and then make sure you add the 100 there. And it is going to give you an approximate. So when you hit enter, it is going to give you approximate 34.183. So then this is the degree of your biscuit, or I should say temperature of biscuit. Biscuit when T equals 10 minutes, okay? So that's the temperature of your biscuit when T equals 10 minutes. Well, let's go ahead and compare that with your T. So what is the temperature of your T when T is 10 minutes? Well, your degree of T is 43. Degree of T at T equals 10 minute is 40 degrees Celsius. Well, let's go ahead and subtract the two so we can see the difference there. So you can label it as temperature of T minus the temperature of biscuit. So that's going to be 43 minus 34.183, which is going to give you a difference of 8.817 degrees Celsius, which means this biscuits are 8.817 degrees Celsius cooler than the t at t equals 10 minutes. And that should be your answer for this question. All right, so now what I want you guys to do is using your scoring guide because they are worth 9 points, okay? So 3 points, 1 point, 2 points, 3 points. Using the scoring guide, I want you guys to kind of go over 2 students' work and you are to assign them a grade. So for student number 1, this is what they wrote. Go ahead and give them a score out of 9 according to the grading scale. And then proceed on with student number 2. This is what they wrote, and then give them a score out of 9. My last question for you guys is comparing what student 1 did with student 2, which one do you think had a better answer? And in which case, what do you take from this experience so that way you can make sure that you're showing the correct and adequate information on your test to ensure that you get a high score of 9. All right, so with that said, if you guys feel like you need some additional practices, go on to your week 14 Wednesday guided notes. I have a little bit more practice by integration by parts. So if you want to do that, that's perfectly fine. And I have the answer link right here. So you just go ahead and click on it. And it is going to give you guys the steps of that. So you can go ahead and take a look and check and make sure that you have the correct answer. All right, you guys, I hope you have a wonderful week. As always, stay safe and healthy, and I'll see you guys on Thursday. Take care.